This recording contains two time-locked potentials. The second potential with higher amplitude is used for triggering, and we are going to assess the jitter and blocking in the first potential. The triggered sweeps shown here in superimposed mode. The second potential used for triggering appears stable on the screen, but the first potential shows a lot of jitter. The jitter in this signal was 259 microseconds, but there was no blocking. The absence of blocking is rather unexpected with such high levels of jitter. When we review the traces, we could confirm that all discharges really had a pair of potentials. There are 10 sweeps that show a lot of variation in the interpotential interval, but no blocking is seen. This pattern is explained as follows. The second potential is generated by the end plate with increased jitter and blocking, now displayed on the first one. Since the second potential was used for triggering, we could never capture the instance when blocking occurred. All jitter was seen in the first potential. If we were to trigger on the first potential, we should be able to observe blocking in the second potential. We will use a lower amplitude for a triggering level. Furthermore, the delay is reduced on the screen to observe the variation of the second potential. Here, the first potential appears constant on the screen and all jitter is seen in the second potential. The second potential is missing on some traces that are seen in red color. This blocking must be confirmed by the operator. Here are 10 consecutive sweeps in raster mode. The second potential is blocked on 2 sweeps. The shape of the first potential is the same on all sweeps, which indicates that it is not an other motor unit that is triggering the sweeps. The jitter is 248 microseconds and 6 sweeps showing blocking. Note that the jitter and mean interpotential interval values are very similar between the two situations where we trigger on the first or on the second signal. Indeed, the choice of triggering potential has no effect on the numerical value of jitter when analyzing a pair of potentials. While it is easier to trigger on the higher amplitude potentials in general, it is sometimes necessary to use the smaller potential to resolve blocking.